Tiende pamozi ndi mtima ummo. Tiende pamozi ndi mtima ummo. Oh, tiende pamozi ndi mtima ummo. 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 Tiende pamozi ndi mtima ummo.
Hello, good morning. Welcome to MTN Teleschool and thank you so much for tuning in. My name's Kasonde Chimpusa from Kafue Boys Secondary School. I am a specialist in mathematics education. So if you have comments or questions, you can simply like our page on Facebook, MTN Zambia, and ask your questions. I will be able to respond to you as soon as possible. You can as well download our application from Google Play Store, MTN TV Plus, and watch all the lessons for free. So today we are going to look at revision of 2017 Mathematics Paper 1. Yesterday you had an opportunity to look at 2017 for general education, for general certificate education mathematics with Anthony, and today we are looking at 2017 Mathematics for ordinary or internal candidates, which is 4024/1. We're simply talking about ordinary level mathematics. So I encourage you to, even tag your friends so that we can revise together. I am so pleased to be on this platform, guys, and just help you revise or prepare for the final examination. So let's quickly look at our first question number 1 from 2017 paper 1. All right, so question number 1 is simplify 3x minus, open bracket, y minus 2x, close bracket, minus 3y. So we have 3x minus, open bracket, y minus 2x minus 3y. So this question comes from the topic called Basic Processes of Algebra. So in order for you to answer this question in the exam, you need to have knowledge on factorization, simplification. You also need to know how to operate algebraic expressions. So how do we tackle this question in particular? Well, we first of all get rid of the brackets. So you need to understand that the question we have 3x minus, open bracket. Now, just before the bracket, we have a 1. So what we need to do is that we need to expand this expression and get rid of the bracket. So how do we do that? We multiply the negative 1, this part. We multiply negative 1 by each term inside the brackets. So when you expand, you are going to have 3x negative 1 multiplied by y, you get negative y. Then negative y multiplied by negative 2x, you get positive 2x. Then we have minus 3y. So what you need to do at this point now, you need to collect the like terms. So you have 3x plus 2x minus y minus 3y. Then when you add 3x plus 2x, you get 5x, you get 5x, and minus y minus 3y, you get minus 4y. So this is our answer. This is our final answer, 5x minus 4y. So 5x cannot be added or subtracted by 4y because these are unlike terms. So that is what you are expected to do in the exam when you're given such a question. I think this is one of the simplest questions you find. It is taught in grade 10. So this is under basic processes of algebra. So let's quickly look at our second question, which is question number 2. All right, so our second question reads 81 over 16 raised to the power negative 4 plus 81 over 16 raised to the power 0. Now our question number 2 comes from the topic called indices. So I will give you a few examples so that I remind you of what indices are all about. So when you look at indices, let's say we have the variable x. And when I write x, there is a power 1, which gives us x. So x raised to the power 1 is simply written as x. Now, when you have x raised to the power negative 1, it simply means that you have 1 over x. So when I write x raised to the power negative 1, I'm simply talking about the multiplicative inverse of x. So in this case, we have been given 81. We have been given 81 over 16 raised to the power negative 1 over 4 plus 81 over 16 raised to the power 0. So the first term, this one, 81 over 16 raised to the power negative 4, can also be written as 1 over 81 over 16 raised to the power positive 4 plus, now you need to realize that any number raised to the power 0 is positive 1. Any number raised to the power 0 is positive 1. So 81 over 16 raised to the power 0 gives us positive 1. So all we need to do now is to simplify 1 over 81 over 16 raised to the power 4 plus 1. So I'm going to distribute the power, which is 1 over 4. We have 1 over 81 raised to the power 1 over 4 over 16 raised to the power 1 over 4 plus 1. So what we have here is that this expression here can also be written as 16 raised to the power 1 over 4 over 81 raised to the power 1 over 4 plus 1. If you have, let's say we have 1 over a over b. This can also be written as 1 over 1 multiplied by b over a, which gives us b over a. So that is the same situation we have on this one here. So what I'm going to do is that I need to find the fourth root of 16. Now finding the fourth root of 16, I will write 16. I'll find a base that I can raise to the power 4 in this case. Okay, so a number that I will raise to the power 4 is 2 in order for me to get 16. So 16 can be written also as 2 raised to the power 4. Then I will have 1 over 4 over, I will do the same with 81. I will find a number that I can raise to the power 4 in order for me to get 81. So that number is 3. So 3 raised to the power 4, you get 81. So 81, 3 raised to the power 4, you get 81. Then I will raise this everything to the power 1 over 4. Now, when you look at the rules of indices, you realize that when you have been given x raised to the power n, then raised to the power m, we are talking about a power of a power. So this, in this case, we multiply the powers and we'll get nm. So we'll do the same. So here we have plus 1. All right, so we have plus 1. Then when I multiply 2 raised to the power 4, the power of 2, when I multiply it by the power of the power, so 4 multiplied by its multiplicative inverse, I'll get 1. So this will give us 2. We'll get a 2 because 4 multiplied by its multiplicative inverse will give us 1. I will do the same with the denominator, which is 3 raised to the power of 4. When I multiply 4 by its multiplicative inverse, I will get 1. So I will have 3, then plus 1. So you simplify this arithmetic expression. What you do is that you have over 1. So you can multiply 2 by 1. You have 2 plus 3 by 1 by this one, 3 and that 1. You get 3, then divided by, you will multiply 3 by the denominator, 1, also you get 3. So the final answer we have 2 plus 3, we'll get 5 over 3. So that is our final answer. All right. So that is how you are expected to answer this question in the exam. So thank you so much, Solomon Njovu, for tuning in. I can read your comment. Thank you so much, Frank Kamara. I can see you are watching. Thank you so much, guys, for showing us the love. Thank you so much, and keep watching. Keep watching. All right. So let us quickly go to question number 3 and see how we can answer that question. All right. So question number 3. The question reads: the gradient of the line joining the points 2 or negative 2 comma k and k comma negative 14 is 2. Calculate the value of k. So when you look at this question, question number 3, it's from the topic called coordinate geometry. Now they are specifically looking at the gradient. So we are given 2 points and they have given us the gradient as 2. They want us to find the value of k. Now, what is gradient? Assume that we have the x or y plane. We have x and we have y. This is the origin, 0. Then we have 2 points. We have a line, and on this point we have A and we have B. You'd find that this point will be x1 and that point will be x2. You let that point be x2. Then you see that change in x from this point will go to that point. So we have x1 and x2. Then this point will be y1 and we have y2 at that particular point. We have y2 at that particular point. So you find that gradient, which is the slope of the line AB, this is change in y over change in x. We are simply talking about the ratio of change in y over change in x, or the ratio of change in y to change in x. So how do you write that mathematically? We are saying that we have gradient is given by y2 minus y1, which is change in y, over x2 minus x1. So now let's go back to the question. We have been given 2 points. The first point is negative 2, comma, k. The second point is k, comma, negative 14. All right. And we are told that gradient is equal to 2. So let's suppose that k is the point x is equal to 2 from the second point. It simply means that from the first coordinate, we have the x coordinate will be x1. Then it means that negative 14 will be y2 and k will become y1. So substituting these parameters into our formula, which is this formula, m is equals to change in y over change in x, we have gradient, which is positive 2. Then we have our y2, we have negative 14, then minus our y1 is k, divided by x2, we have k, then minus our x1 is negative 2. So this will give us 2 is equal to negative 14 minus k divided by k. Positive times negative, you get positive. So you have positive 2 when you multiply the negative outside the bracket by the negative on negative 2. So you get positive 2. Then we understand that all integers are rational numbers. So I'm going to write the 2 on the left hand side of the equation as a rational number. So 2 as a rational number will be written as 2 over negative 1. So since we have fractions on both sides of the equation, we can simply cross multiply. So I will cross multiply, and this will give us 2 multiplied by k plus 2 equal to negative 14 minus k. So I will expand the left side. I will have 2k plus 4 is equal to negative 14 minus k. Then I will collect the like terms in this case. So I will transpose negative k. I will have 2k. Then when I transpose negative k on the right hand side of the equation, I will have plus k. Then equals negative 14. When I transpose positive 4, I will have minus 4. So 2k plus k, I will get 3k. Minus 14 minus 4, I will get minus 18. Then I will multiply both sides by the multiplicative inverse of 3, since I want to make k the subject of the formula. So multiplying both sides of the equation by the multiplicative inverse of 3 is as good as dividing both sides by 3. So I will divide both sides by 3. So 3 into 3 we get 1. 3 into 3 we get 1. Let me make one point clear, guys, here. When you are dividing a number or the coefficient of a certain variable by the multiplicative inverse of the coefficient of that particular variable, you don't cancel. You simply divide. So 3 and the other 3 will not cancel, but 3 will be divided into 3, and the numerator, which is the coefficient of k, will also be divided by 3. Then the denominator 1 will be divided into 1, which will give us 1, and then 1 multiplied by k. That is how we get k. It is not that they will cancel. No. So that is how you do it. Then when you divide positive 3 into negative 18, so this 3, the denominator is positive. So when I multiply positive by negative, I will get negative. How many times can 3 go into 18? Or I'm dividing 18 by 3. So 3 can go into 18 6 times. Therefore, the value of k is equal to negative 6. We can verify by substituting the value of k into the coordinates, which is our first coordinate, coordinate number 1, and coordinate number 2. Then substitute the actual values of k into equation number 1, and you will get the value of m as positive 2, which is the value of gradient. All right, guys, so that is how you answer question number 3. Now, just in case you just tuned in, we are watching MTN Teleschool, and if you have comments or questions, you can simply go to our Facebook page, MTN Zambia, like our page and ask your questions. I will be able to respond to you in time. You can as well download our application from Google Play Store, MTN TV, and watch all the lessons for free. All right, guys, let's go to question number 4. Question number 4. All right, question number 4. Factorize completely. We have a x squared minus 1 minus 4ay cubed. So this question also comes from the topic called basic processes of algebra. So they want us to factorize this question. So how do you factorize a question like this one? Well, you look at the common factors. That is how we are factorizing. Okay, so when you look at the first term, you have ax squared y minus 4ay cubed. So you can see from the terms that we have that a from the first term is common. We have a, and we also have A on the second term. So we are saying that A is common. So we can write our A like that. Then when we look at the next variable, which is x, the first term has a variable x, but the second term, we do not have the variable x on the second term. So x is not common in this case. Then when you look at y, we have y on the first term, and we also have y on the second term. Now, when you look at the degree of y, which is the power of y, is 1. Then when you look at the power of y on the second term is positive 3, implying that y is common. So I will get y as a common factor in this case, because we only have one y here, which is raised to the power 1. So these are the only variables I have that are common. So I will now open the brackets. So when I divide ay into the first term, I will get x squared. Then minus, because this value is positive, which is the common factors are positive. So when I multiply the positive value by the negative sign, which is here, I'll still get negative. Now, when I divide this common factor into 4ay cubed, I will get 4y squared. All right. So this is, let me call it star 1. So when you look at star 1, the term inside the bracket will now is a quadratic, is a completing of the square. So how do we work that one out? We use what we call completing of the square method. So how does it work? Let's say I have x squared minus 1. We realize that 1 can be written as 1 raised to the power 2. So factorizing this one using completing of the square method, we'll have x minus 1, then we'll have x plus 1. So getting back to star 1, we have ay, then the term inside the brackets can be written as x minus, then I'll find the square of positive 4, which is 2 squared, then y squared, like that. Then I will have ay, then factorizing the term inside the brackets by completing of the square method, I will get x minus 2y, then x plus 2y. So this is our final answer. So that is what you needed to do on that particular question. All right. So that is question number 4. Let's look at question number 5. All right, so question number 5, the points P and Q have coordinates 2, 4 and -3, 1 respectively, implying that 2, 4 is the point P and Q is the point -3, 1. Now the question is, express the vector PQ as a column vector. Express vector PQ as the column vector. So question number 5 comes from the topic called vectors. So in order for you to answer this question, you need to have knowledge on directional vectors and position vectors. So let me give you an example. We look at the diagram. Let's say we have, this is x and this is y. So the point P is 2, 4. So assume that we have 2 there, then we have 4. So the point P is somewhere here, which is point P. Then we have -3, 1 as point Q. So we have -3, +1, which is somewhere there as point Q. So when I connect the 2 points, which is P and Q, I will get the vector PQ will be in this direction. Now, what you need to understand is that writing the vector P as a position vector, it means that I will connect this point P to the origin. Like that. So this will make vector OP as a position vector. Then, connecting the point Q to the origin will also give us a position vector Q, which is OQ. Alright. So, getting the position vector of OP will give us 2 and 4 as a position vector, which is vector OP. And the position vector OQ will give us -3, 1. So, how do we find PQ? We are moving from the point P going to the point Q. So how do we get the vector? So vector PQ will be given by, we move from P to the origin, which is in this direction. So we'll move PO, then plus OQ, plus OQ, plus OQ. Now, when you look at the position vector of OP, OP is position vector 2, 4. So since I am moving from P going to the origin, I am going into the opposite direction. So when I am moving in the opposite direction, I multiply the vector by a -1, which is a scalar, -1, because I'm moving in the opposite direction. So since OP is equal to 2, 4, then PO, vector PO will be -2, 4. So substituting the vector PO into *1, we are going to have PQ is equal to -2, 4 plus the vector OQ is -3, 1. So multiplying the vector 2, 4 by the scalar, which is -1, we get -2, -4 plus -3, 1. So we have two column vectors. We simply add corresponding terms. So we have -2 plus -3. So our answer will be -2 plus -3. Then we have -4 plus 1. Therefore, the vector PQ will be equal to, when I multiply this positive by the negative, I will get negative. So we have -5, which is -2 minus 3, we get -5. Then -4 plus 1, we get -3. Therefore, the vector PQ is equal to -5 -3. So that is what you needed to do on question number 5. So just in case you are having challenges, guys, just make sure that you study very smart and you go through these concepts. This is a very simple question and it's a very simple topic. You can do it. All right. So we can quickly go to question number 6. But before we look at question number 6, let's just have a quick break. I will be back after 1 minute or so. So don't go away. Stay tuned.
Rise up this morning, smile with the rising sun. 3 little birds pitch by my doorstep, singing sweet songs of melodies pure and true, saying, this is my message to you. Singing, don't worry about a thing, 'cause every little thing is gonna be alright. Singing, don't worry about a thing, 'cause every little thing is gonna be alright.
use your data is up to you. With the widest network coverage, it's amazing what you can do on MTN.
This is my message to you.
It's free. It's all free.
Imwe, twanya again and again. MTN brings you an even bigger, bolder, more delicious offer. Matemeto DVD. Stream, download, browse, and upload without using your data for 1 whole month. Get free Instagram, MTN TV Plus, free MTN Music Plus, Facebook Flex, and free WhatsApp when you get Matemeto DVD. It's incredible. All you have to do is recharge with 2 kwacha and get it all for free without using your data. Offer is valid up to midnight of the same day. Terms and conditions apply.
Everywhere you go, MTN.
All right, guys, welcome back. You're watching MTN Teleschool, and thank you so much, guys, for staying with me and just for tuning in. Philip, I've seen your comment, and I will slow down for your sake. Thank you so much for that comment. Guys, keep the comments coming, and if you have questions, you can ask your questions. I will look at it as soon as possible and get back to you. All right, so I've also seen that King is watching. Kennedy, thank you so much for that comment. Kennedy K. Kalunga Kawe, thank you so much, and keep loving Yellow. Thank you so much. All right, so let's get back to our lesson and look at question number 6. All right, so question number 6, we have a question on sets. We have B complement intersection A intersection C. So we have been given a Venn diagram. We have 3 sets. We have the universal set. We have A, B, and C. So now the question is, shed B complement intersection A intersection C. So when you look at A intersection C, A intersection C is this part and that part. So we have this part here as A intersection C. Then we have another operation, which is a set operation intersection, meaning we have intersection B. So when we have intersection B, we are including this set here. But when you look at the operation that we have there, we are saying intersection B complement. So by implication, we are excluding the set B, which is this one, set B. Now imagine the area we had was actually this one, which is A intersection C. So when we exclude B, we'll simply remain with this part here when B is excluded. So the area for A or B complement intersection A intersection C, the solution will just be in this area here, which is this part. That is A intersection B. That is B intersection B complement intersection A intersection C. So I'll just encourage you guys to look at the Morgans as you look at set operation. When you have A union B complement, this is the same as A complement intersection B complement, and when you have A intersection B complement, this is the same as A union B complement. So guys, you can look at this. This rule is very helpful and it will help you actually answer questions on sets without problems. All right, so let's quickly go to question number 7. Question number 7. All right, guys, so we are simply talking about mathematics and we are looking at mathematics paper 1. We are specifically looking at 2017 mathematics paper 1. So guys, If you have questions or comments, just like our Facebook page, leave your questions there and comment. I will answer you as quickly as possible, as soon as I can, guys. So don't worry about that. All right, we look at question number 7. The question number 7, we have been given two matrices. So we have given that A is a matrix 3, 2, 1, 4, 3, 0, and B is a matrix 1, 2, 3, 3, 2, 1, 0, 1, 2. So we have A, 2, 1, then we have 4, 3, 0, and we have matrix B, which is equal to 1, 2, 3, 3, 2, 1, 0, 1, 0. All right. So the first question is find A transpose. Find A transpose. Now, what is a transpose matrix? Well, when you are given, let's say you have been given matrix X with elements A, B, C, D, E, and F. So when you look at the matrix X, you have the order of the matrix X is a 2 by 3 matrix. We have 2 rows. We have 2 rows and 3 columns. So when we are asked to find the order or the transpose of matrix X, it simply means that rows will become columns and columns will become rows. So if we are finding the transpose of X, then it means that the order of that transpose matrix will be a 3 by 2. Why? Because rows will become columns and columns will become rows. So how do you make this one? It means that the first row will become the second column and the second row will become the second column. So in this case, when you are given X, which is A, B, C, D, E, and F, then it means that the transpose matrix of X will be A, B, C. As you can see, the first row is now the first column, and the second row, which is D, E, and F, will become the second column. So when you look at the order of this matrix, you get 3 by 2 because we have 3 rows. We have 1, 2, 3, which are rows, and we have 1, 2 as columns. All right. So getting back to the question, you have been given 2 matrices. You have matrix A, which is 3, 2, 1, 4, 3, 0, and you have matrix B, which is 1, 2, 3, 3, 2, 1, 0, 1, 2. I'll call this as star 2. So if you are to find the transpose matrix of A, you have A as 3, 2, 1, then 4, 3, 0. Then the transpose of A will be given by the first row will become the first column. So you have 3, 2, 1, and the second row will be the second column, which is the 3, which is 4, 3, 2, and 0. So this is our A transpose matrix. Remember, guys, a transpose matrix, in a transpose matrix, you simply have the number of columns become the number of rows, and rows become columns. So if you have a 3 by 2 matrix, it means that its transpose matrix of that particular matrix will become the opposite, or it will become the inverse, or it will become, let me say, it will become it will become a commutative kind of multiplication. So if you have the order 3 by 2, then the transpose will be 2 by 3. Okay, so that is how you answer question number 1. Question number 2, which is B, okay, part B, you have A, B. So they are asking you to express the matrix AB as a single matrix. Now, when you have AB, you agree with me that AB, we are multiplying A times B. So when you are given AB, it's as good as multiplying the matrix A by the matrix B. So AB, we are saying AB is equal to matrix A is 3 to 1, 3, 4, 3, 0, and then we have 1, 3, 0, 2, 2, 1, we have 3, 1, 0, like that. Okay, so how do you multiply matrices? The first thing that you need to do, you have to check that the two matrices before are multiplied, they are conformable. Now, what is the principle of conformability? Conformability states that the number of columns in the first matrix must be equal to the number of rows in the second matrix. So when you look at the first matrix, which is A, you have 3 columns, which is 1, 2, 3. Then in the second matrix, you have 3 rows, which is 1, 2, 3. So it simply means that the two matrices, which is A and B, are conformable, meaning that the number of columns in the first matrix are equal to the number of rows in the second matrix. All right, so how do you operate, or how do you multiply matrices? We multiply rows by columns, meaning we are multiplying corresponding terms in the rows by their corresponding terms in the columns. So we have A multiplied by B. So I'm going to multiply A multiplied by 1 in the next matrix. So we have a 3 here. It will be multiplied by the first term. So the first term in matrix A will be multiplied by the first term in matrix B. So 3 multiplied by A by 1, I will get positive 3. Then 2 will be multiplied by positive 3. So 2 times 3, I will get 6. Sorry. So 3 multiplied by 1, you get 3. Then you sum, you add, you have plus 2 times 3. I'm multiplying this 2 by this 3. So 2 times 3, you get 6. Then plus 1 multiplied by 0, you just get 0. So this is our first term. So first row, second column. First row, second column, I will multiply corresponding terms in the first row by corresponding terms in the second column for me to get the value for the matrix that we will have, or for the value that we will have, or an element that we will have in the first column, in the first row, second column, which is this part here. All right. So 3 multiplied by 2, we get 3. Then plus 2 multiplied by 2, I'm multiplying this 2 by that 2. So I will have 4. Then 1 by 1, you get 1. So let me just write this properly, because, all right, space. All right, so 3 by 1, we had 3 plus 6, then we add 0. So then we'll have 3 multiplied by 2, we get 6. Then 2 multiplied by 2, we get 4 plus 1. Then 3 multiplied by this 3, we get 9. Then plus 2 multiplied by 1, we get 2. Then plus 1 multiplied by 0, we get 0. Okay, so we have all the elements in the first row. Then we go to first row, we are multiplying now elements in the second column, I mean in the second row, which is this one. Okay, so let me still multiply this one, elements in the first row by elements in the second row, which are these ones. Okay, so I will multiply by this, that, and that. So the next thing you do is, since we are multiplying these elements by these elements in column 1, column 2, and column 3. So we will now multiply elements in the second row by elements in column 1, column 2, and column 3. So we have 4 by 1, we have 4, then plus 3 by 3, we get 9, then 0 by 0, we get 0, then we have 4 by 2, we have 8, then plus 3 by 2, we get 6, 0 by 1, we get 0, then we have 4 by 3, we get 12, then plus 3 by 1, we get 3, then 0 by 0, we get 0. So we'll have that. So how do you tell? Let's say we are multiplying two matrices. How do you know the order of the matrix solution that you get, or the solution that you get? So you have the matrix A as the order 2 by 3, matrix A as order 2 by 3, then matrix B is 3 by 3. So the answer will have the order 2 by 3. As you can see, we have 2 rows, which is 1, 2, and we have 3 columns. So I will just simply simplify this one. When we have 3 plus 6, we get 9. So 6 plus 4 plus 1, we get 11. Then we have 2 plus 9, we have 11. 4 plus 9, that gives us 13. Plus 0, we still get 13. Then 8 plus 6, we have 14. And 12 plus 3, we get 15. We get 15. Therefore, the matrix AB is equal to 1, 1, which is 11, then 13, 14, and 15. All right. So that is how you answer question number 7. All right. So the other thing you need to know on matrices is that you need to know how to find the determinant. You also need to know how to find the adjoint of a matrix, and also how to find the inverse of a matrix. Sometimes they will ask you to find the inverse of a matrix, and for you to find the inverse of a matrix, you need to know how to find the determinant of a matrix. You need to know how to multiply two matrices. So this concept is very, very important, because you will need it when you start multiplying, or when they ask you to find the inverse. You will need the concept of multiplying two matrices. So this is very, very important, guys. You need to make sure that you look at it critically and see how best you can work it out. All right, so let's look at question number 8. Question number 8. We move on and look at question number 8. Thank you so much for all the comments. Yeah, Mokuka, I can see you're watching. Thank you so much for joining us. Bibiana, thank you. Isaac, Mucho, Chela, thank you so much, guys. You can ask your questions if you have any, and I will respond to you as soon as possible, guys. Thank you so much for showing us the love. Okay, guys, so we look at question number 8. Question number 8. Question number 8 is, for the sequence 25, 22, 19, 16, ... Find the term, or find the formula for the nth term. All right, so we just focus on the sequence that we have been given. So this is a sequence. Okay, we have been given a sequence. Now, when you look at sequences, the progression can be different. So, in syllabus D, you are expected to look at two types of progression. One is arithmetic progression, and the other one is geometrical progression. So, under arithmetic progression, we have the aspect of a common difference. And in geometrical progression, we have the aspect of a common ratio. So when we look at the sequence that we are given, we have 25, we have 22, 19, 16. We can see that the pattern there is that numbers are reducing. But how are they reducing? Are we subtracting? Are we dividing? Or what is it that we are doing? So we need to check if this kind of a series is under arithmetic progression, or if the progression is arithmetic, or if the progression is geometrical. We need to check. So how do you check? We'll first of all look at the consecutive terms. Under arithmetic progression, you need to find the common difference, and you can find the common difference by finding the difference between two consecutive terms. So when you look at term number 1, which is 25, and we have the second term, which is 22. When I find the difference, that is 25 minus 22, I'll get the answer minus 3. So I will try to find the difference between 22 and 19, because 22 and 19 are also two consecutive terms. So 22 minus 19 will still give me negative 3. So you can see that the difference between two consecutive terms is negative 3, which is common, and therefore this kind of a sequence is under what we call arithmetic progression. Now, what do you need to know in order for you to answer questions on arithmetic progression? You need to know how to find the nth term of a progression. So, how do you find the nth term of a particular progression? We know that the nth term of a sequence will be given by a plus n minus 1 d. So we have star 1 here, where a is the first term, a is the first term, n is the nth term, and d is the common difference. Is the common difference. So what is the value of a? Value of a, in this case, when we look at our sequence, this one, we have 25, which is 25. Then value of d, which is the common difference, we have negative 3, which is this one. Okay. So the question is, find the formula for the nth term. We are not given the value of n, so we just need to simplify our formula and find the simplified formula in nth term. Okay. So when we look at equation number 1, which is a star 1, we have Tn equals, so where there is a, I will substitute by 25, so we have 25, then plus n minus 1, and our common difference is negative 3. Okay, so this will give us 25. Now I will first distribute this negative 3 by expanding, which is I will multiply negative 3 by each term inside the brackets here. So this will give us plus negative 3 times n, I'll get negative 3n, then minus 1 multiplied by minus 3, I'll get positive 3. So this will give us 25 plus, so there is a positive 1 outside, so we have negative 3 plus 3. So multiplying positive 1 by each term inside the bracket, there we have 25. Positive 1 multiplied by minus 3, I'll have minus 3n. And then positive 1 multiplied by positive 3, I'll get positive 3. So collecting the like terms, 25 can be added by 3. So when I add 3 to 25, I will actually get 28, then minus 3n. Therefore, the nth term will be given by 28 minus 3n in this case. So this is how you find your formula for the nth term in terms of n, because we don't know what the value of n is. Okay, so if you have this as your nth term, for example, you have we have 1, 2, 3, we have 4 terms. If I ask you a question using the same series or using the same sequence, if I ask you a question to find, let's say, the 6th term, or you find the 5th term or the 6th term, it means that our n will be equal to 6. Therefore, let's call this star 2. Therefore, substituting n in star 2, we'll have T6, which is equal to 28 minus 3. Where there is n, I'll put positive 6. So we have 28 minus, all right, so I'm multiplying minus 3 by positive 6, and I will get positive minus 18. I will get minus 18. So 28 minus 18 will simply give us 10. Of course, this is not part of the question, but I'm just using it to help you, see how you can use this term that you have been given, which is a star 2. How you can use star 2 to find terms in a sequence. All right, so let's get back to our question, which is question number 8, and look at part B. All right, so part B, find the sum of the first 20 terms. Okay, find the sum of the first 20 terms. Now, if they ask you a question that you need to find the sum of the first 20 terms, you need to picture a situation where you have used this term, or the general term, which is Tn is equal to 28 minus 3n, to find each term, okay, to find each term, or to find all the 20 terms in that particular sequence. Then you add all the terms and find the sum of all these terms. So when you look at that process, it is very long, because sometimes I can ask you to find the sum of 1,000 terms or the sum of 100 terms. So how do you do it? All right, so sum of the nth term will be given by Sn, which is n over 2, open bracket, 2a plus n minus 1 d, close bracket. All right, so since they want us to find the sum of 20 terms, meaning that n will be equal to 20, our a is equal to 25, and d is equal to minus 3. So substituting these numbers in star 3, we have S20 will be equal to 20 over 2, then open bracket, we have 2 multiplied by 20, then we multiply by 25, because our first term is 25. Sorry, okay, so we have 25 plus our n is 20 minus 1, then our common difference is minus 3. Right, so simplifying this, we have S20 will be equal to 10, then 2 times 25, you get 50. You get 50, then plus 20 minus 1, you have 19, then you multiply 19 by 3. So when we simplify this, we'll get 10. Then we have 50 minus 57, and that will give us 10. 50 minus 57, you get minus 7, and 10 multiplied by negative 7, you get negative 70. Therefore, the 20th term of the sequence is negative 20. So you can verify this by just finding all the terms, all the 20th terms, by using the general term of the nth term, which is Tn is equals to 28 minus 3. You can find all the terms, all the 20 terms, and sum them up. You will see that you get the answer, which is the sum of all the 20 terms, as negative 70. So the sum will be negative 70 because of the common difference. We can see that when we look at our original, or when we look at the given sequence is in decreasing order. So by the time we reach at the 20th term, obviously we'll go into negatives. And that is why we have our sum as negative 70. Negative 70. Alright, so that is how you work out question number 8, guys. Number 8. So thank you so much, guys, for watching us. Right, thank you so much, guys, for staying with me. I'm your presenter, By Kasonde, and I'll be back with another presentation at 11 hours. So make sure that you invite your friends, invite everyone and your family, and just watch with them, guys. You can as well download our application from Google Play Store, MTN TV Plus, and watch all the lessons for free. So thank you so much, guys. I'll see you.
It's free. It's all free.
Imwe, Twalia again and again. MTN brings you an even bigger, bolder, more delicious offer. Matebeto DVD. Stream, download, browse, and upload without using your data for 1 whole month. Get free Instagram, MTN TV Plus, free MTN Music Plus, Facebook Flex, and free WhatsApp when you get Matebeto DVD. It's incredible. All you have to do is recharge with 2 kwacha and get it all for free without using your data. Offer is valid up to midnight of the same day. Terms and conditions apply.
Everywhere you go, MTN.
Tiende pamozi ni mtima umo. 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 Tiende pamozi ni